Hi, so now we really come to the meat of the course. So these skills that we're learning now, the differentiation rules, are going to be used like in every other math class that you ever take for the rest of your life. And so these are the most fundamental rules too. This rule, the power rule, lets you take the derivative of a polynomial and then e to the x is a function that comes up a lot in applications, and it also has a really simple derivative. So what I'm going to do now is I'm just going to do some of the even-numbered problems in the textbook on page 181, and now I'm just going to let myself loose and sort of do them. So in each case, the goal is just to find the derivative. So I wish maybe, I don't even know if I need to talk. I wish I'd planned to play some music now or something. Maybe that classical music song, Flight of the Bumblebee, or Eye of the Tiger from Rocky. So I'm just foiling this out. And so what I just did, x times 2x, now I've got 3x, now I've got minus 4x, and now I've got minus 6. Okay, I haven't taken the derivative yet. When I say equals, generally I really mean equals, and you should be careful to do that yourself also. Now we can combine these like terms. 2x squared, this makes minus x, and minus 6. Alright, so this is just h, and now let's find h prime, and just to practice using the notation, sometimes we might write this as dh dx. So these are just two different ways of saying the same thing, the derivative of the function where x is the variable. So let's use the power rule in each place. So we've got 4 times x, and so remember the simplification of the power rule, or the special case, just says that the derivative of the variable is 1. So that's really what I'm doing in my head here. The derivative of x is 1. The justification for that is this. So if you take the derivative, then the 1 comes down and becomes a 0. And then you've got 1 times 1 is 1. So instead of just doing that over and over again, you just remember that you take the derivative of a variable, it becomes 1. And similarly, the derivative of a number is always 0. So the derivative of 6 is 0, so I'm not even going to write it. And that's it, all right? And I'm just getting started. So now let's go on to b of y is equal to c times y to the minus 6, where c is a constant. So now c is a letter that's standing for some number that's not the variable. So y is the variable. If it makes you feel better to write 5 instead of c, you can do that. It should be exactly the same. So what is b prime? Same thing as db dy, right? Now, why is it y down here? Is because now y is the variable. And these are just two different notations for the same thing. So the negative 6 comes down, you ignore the c, now take 1 away and it becomes minus 7, and you're done. So let's keep going. Now I've got y is equal to x to the 5/3 minus x to the 2/3. So what is y prime? Otherwise known in this case as dy dx. Y, Sir Stotley, it's equal to 5/3 x, and now I take 1 away, so that makes this 2/3, and minus 2/3, and x, now take 1 away, and that becomes minus 1/3. We did this problem in class. Okay, so that one's done. Keep going. H of t is equal to the 4th root of t minus 4 times e to the t. Okay, so now dh dt is the derivative. So the 4th root is the same thing as the 1/4 power. Okay, so when I take the derivative here, the 1/4 comes down. Now I take 1 away from 1/4, and that is minus 3/4. Leave the constant alone, take the derivative of e to the t, which is just e to the t, and you're done. Okay, next one. So by the way, I'm assuming that you guys are as you watch this video, you're just pausing it if you want to. It won't offend me if you just pause it. You could even pause it for a second and, whatever. So here we've got square root of x times x minus 1. Alright, so this is a little trick. First we need to multiply in, and we're going to have, when we do this distribution, we're going to have square root of x coming face to face with x. So what's going to happen when these two collide, you're going to have this 1/2 power is going to add with this power of 1 and make x to the 3/2, right? So this is x to the 3/2 power minus square root of x. By the way, I know that maybe there's probably at least one person that doesn't understand what I just did. And in that case, just email me or come chat something. The exam isn't until the 26th. Now let's find y prime is equal to 3/2 and take 1 away and it becomes 1/2 minus 1/2 times x to the minus 1/2. See why that happened? That's because the radical is the same as the 1/2 power. And that one's done. And the next one is s of r is equal to 4 pi r squared. And now we want to find s prime of r, which is the same thing as ds dr, because r is the variable. Now, it's tempting to get freaked out by pi, but pi, remember, is just a number, so in other words, a constant, so we just ignore it. So the 4 pi gets ignored, the 2 comes down, you subtract 1, and you're done unless you want to combine these and make 8 pi r. Right? So that is the answer. And so the next one, y is equal to the square root of x plus x over x squared. Alright, so this is a little bit of a simplification problem first, and it's sort of the kind that we practiced in the algebra review question. That's one of the reasons I wanted to do that. So we've got a plus in the numerator. Whenever that happens, you can split up the fraction. So I'm splitting up the fraction because the plus is in the numerator. Right? And now in each one of these simpler, smaller fractions, I'm going to do some cancellation. You've got a 1/2 power on top, power of 2 on the bottom, and so this is 1/2 minus 2. Okay, so that's how you combine the powers. When there's the fraction, it's subtraction. Now similarly over here, I have x to the 1 minus 2 power, because it's x to the 1 on top and 2 on the bottom, so you subtract. And notice that we haven't taken any derivatives yet, but we're almost there. This will be the minus 3/2 power. This will be the minus 1 power. Now we're finally ready to take the derivative, and y prime is equal to minus 3/2 x to the minus 5/2 minus x to the minus 2. Okay? Done. The next one is g of u is equal to the square root of 2 times u plus the square root of 3u. Okay, very important difference here between being in the radical and not being in the radical. See? And so I'm going to smarten this one up a little bit before we get started. The square root of 2, of course, is just a number, so we're going to ignore that. But this is going to be this is the same thing as the square root of 2 times the square root of u. And there's some exception to this, like if both numbers are negative or something, but that is not the case here because 3 is positive. So that's fine. And now we're ready to take the derivative, g prime, also the same as dg du, right? And this is equal to, now the derivative of the variable is 1, so it's square root of 2. Ignore the constant, square root of 3. The 1/2 comes down, and a minus 1/2 is left in its place. And just for fun, I'm going to write this in a different form. We could stop now if we want. But this is the same thing as the square root of 3 over 2 times the square root of u. Okay? And if you don't immediately see why that's true, maybe think about it for a second. But I'm going to go on to the next problem. And so k of r is equal to e to the r times, plus r to the e. Okay, so now the variable is r, and we want to find k prime, which is the same thing as dk dr. And so this is just e to the variable, so it stays the same. Now this is a trick. Remember, e is basically 3. It's 2.718281828. So what you've really got here is just something of the form x to the n, but the letters are different. Instead of the variable x, they're using r. Instead of n to stand for a real number, there's the particular real number e here. So you still have to use the differentiation rule, which brings the n down and takes 1 away. So I'm not going to let the fact that these are weird letters scare me. I'm just going to follow the rule. So this is plus e times r to the e minus 1. And that's it. And so there's at least one more here. It's the last one in the column. It says y is equal to a times e to the v plus b over v plus c over v squared. Now v seems to be the variable, but yeah, it's ambiguous, but it looks like v is the variable. So let's find y prime. And notice how the Leibniz notation is a little bit more precise, right? Because Leibniz notation is totally unambiguous about what the variable is. It says that it's v. So ignore the constant a. A is standing for just some number like 7. So this stays a to the v. Now this part is the same thing as b times v to the minus 1, right? So the minus 1 comes down and gives us minus b. And now take 1 away and it becomes minus 2, right? And now this part is the same as c times v to the minus 2, right? And so the minus 2 comes down. Should change that to a minus sign. So the minus 2 comes down, c is still there, and 1 more gets taken away, and so this is the answer. That one, little abstract, huh? 'Cause all the constants were represented with letters. What else? Let's see if it keeps going on the other page. Yes. So we've got v is equal to square root of x plus 1 over the cube root of x squared. And I'm going to FOIL this out. So this is equal to x, because the square root squared is x, right? Plus 2 times square root of x over the cube root of x. And finally, I have, so what is this really? This right here is x to the minus 1/3. And when I square that, I'm going to get, squaring this just multiplies in 2 to the exponent, and it becomes minus 2/3 like that. Okay, great. And I'm going to rewrite this line before I take the derivative, because this is a little complicated. So what is this standing for? This is standing for x to the 1/2 over x to the 1/3. So this whole thing is really x to the 1/2 minus 1/3, which is x to the 1/6. And I think that's right? I'm going to have to do it out because I'm dumb. So 1/2 times 3 over 3 minus 1/3 times 2 over 2. And so this is 3 minus 2 over 6 is 1/6. I'll never doubt myself again. Yes, this is x to the 1/6 power plus x to the minus 2/3 power. Now we're finally ready to take the derivative, and so that is v prime, or dv dx. And let's go. So 1 from x plus 2 times 1/6. And now take 1 away from 1/6, and that gives you minus 5/6. Plus the negative 2/3 comes down, and don't know why I wrote that weird shape. The minus 2/3 comes down, and take 1 away and you get minus 5/3. So sorry this is a little ugly, so let me circle the answer. So I think that's enough. You should keep doing them. If you haven't done like 100 of them, then you're studying wrong, because you need to do that. And it'll really pay off in the long run. And so that's the end. That's the whole exam.